Hello and welcome back to the InterDrone Podcast, your 30,000-foot view of the commercial drone industry. It is Tuesday, November 3rd, Election Day 2020. My name is CJ Smith, joined today with Michael Peel, Chairman of InterDrone, and our special guest today, Jennifer Andrews. She serves as the NASA SIO Systems Integration and Operationalization Project Lead on Bell's Technology and Innovation Team. She's an InterDrone featured speaker. We'll be speaking to her at InterDrone Online December 15th through 17th later this year. And really excited to have her on. Bell obviously has a long history in traditional aviation. Excited to hear kind of what's top of mind for Bell and some of the work they're doing with regards to drones and unmanned systems. So Jennifer, thanks again for being here. For anyone who's not familiar with Bell, could you give us a brief overview of how Bell works within traditional aviation, maybe some of the work they're doing in drones, and then briefly touch on your role at Bell and on the innovation team there.
Yes, thank you for having me here today. Bell has been in the industry of aviation for over 85 years. We've focused in on both innovative ideas as well as looking at vertical lift solutions. That includes helicopters, tilt rotors, and while it seems like drones have been in the more recent forefront for Bell, we've actually been looking at drones for over 30 years.
And so 30 years looking at drones, what did that look like? If we're talking about 20, 30 years ago.
So in the 90s, which I hate to say was over 30 years ago, we were looking at Eagle Eye, which was a small tilt rotor drone. I guess small is relative. It was not a Part 107. It was actually a relatively large size vehicle. And then, as we transition forward, we were working with the Fire Scout with Northrop Grumman, which is a unmanned 407 that's been worked on. And as we kind of move more forward into current day, we've got the V247, which is a military platform for large support and transport of cargo and systems. We've got the autonomous pod transport, which is the project that I'm working on and supporting. It's called the APT. It's a family of drones. We've got a small Part 107 that's the APT 20. And then we have the APT 70, which was what we utilized for the SIO activity. And it's got the capability of 70 pounds of payload and came in at weight about 300 pounds gross weight. And it has the ability to be scaled up to larger vehicles. And then in addition to that, you've got the air mobility activity that's looking at optionally piloted vehicles as well.
And you mentioned you just finished up a project with NASA. What can you tell us about that?
That's the very exciting project. Completed was a 2-year partnership with them, and we looked at beyond visual line of sight technologies and the pathway towards certification for those. Our effort included taking the APT 70, flying it in and out of Class B airspace here in the Dallas-Fort Worth area. And so that was a very exciting opportunity to look at detect and avoid technology with X-Wing, which is a small startup out of California. We also utilized, in terms of avoidance, out of the University of Massachusetts in Amherst, CASA. They looked at weather avoidance, and we had some displays that showed alerting and weather monitoring during the flight. And then we also looked at an in-house developed system that integrated radios for a robust, redundant command and control system.
Sounds like there's a lot of nuance in there. How do you, and measuring how these systems all integrate with each other for a successful kind of outcome. How do you herd all those cats?
Very carefully. Focused So there was a lot of focus on safety, a lot of focus on discussions with the FAA and NASA to ensure that we not only met air safeties, but also safety on the ground. So we sat down and outlined a plan and executed that effort.
We'll dive into that a little bit more in the second half of this recording. If anybody's tuning in for the first time, we like to talk about a couple of articles from the past week. We'll be talking about the Department of Transportation's announcing the Beyond program, which continues where the IPP left off. We'll be talking about Vantis, North Dakota's new UAS BVLOS network. And then lastly, I'd love to get Jennifer's insight on a new Raptor-inspired drone with morphing wings, which apparently is giving this type of aircraft new flight agility. So without further ado, the U.S. Secretary of Transportation, Elaine Chao, has announced that the 3-year integration pilot program has ended of October 25th. The program will now move to the next phase, which is named Beyond. A Department of Transportation announcement said that the 9 state, local, and tribal governments who participated in the program have signed new agreements with the Federal Aviation Administration to continue to tackle remaining UAS integration challenges. So the 8 of the 9 participants selected for the IPP will participate in Beyond, including the Choctaw Nation of Oklahoma, Innovation and Entrepreneurship Investment Authority of Virginia, the Kansas Department of Transportation, Memphis Shelby County Airport Authority, North Carolina Department of Transportation, North Dakota Department of Transportation, City of Reno, Nevada, and University of Alaska Fairbanks. So Mike, let's kick this over to you first. IPP ending. What do you make of this news and the DOT's kind of commitment to continuing federal testing and is this kind of a show of commitment to building a sustainable industry for UAS here in the States?
Well, so I guess they had a couple of choices ahead of them, right? They could extend the program. This kind of transformation, though, I think speaks to probably too large of a pool of kind of candidates in the initial run, and that they're consolidating probably rather intelligently around where they think they can see success, which is good from a monetary standpoint in providing focus towards actually, feeding into the sites that are producing results. So I'm really kind of excited on that point that there seems to be a lot more focus. It's got a better name, so that's also a good kind of push towards a public acceptance, a raised awareness about what the results will be. Once you get out of acronym territory and it has a name like Beyond, they're bringing in the PR people on purpose. So, I'm just kind of excited to see next steps. I feel like there hasn't been as much progress at the speed we would want, but we say that all the time in the drone industry, right? We feel like the technology outstrips our ability to kind of test that technology at scale and fit into regulations and have the regulations actually fit what we know is capable. So, that's kind of my take on it. I think it's a necessary and intelligent evolution of what we previously had.
Yeah. Jennifer, any thoughts on kind of the state of testing here, the federal investment and the IPP program, and I guess beyond, and what comes next?
Bill actually had the pleasure of participating in the Choctaw Nation of Oklahoma's IPP. So we're honored to see that the FAA and the DOT is providing an additional commitment going forward for this and building on all the lessons learned that the IPP captured.
What are some of those lessons from kind of your little corner of the original program, the IPP program?
I think some of it is related to that beyond visual line of sight technology, looking at testing that can be done to enhance routine operations of UAVs in urban or rural areas, to be able to reach those communities and show a value to them and continue to build confidence in the use that the UAVs bring to the everyday person.
Yeah, I mean, I just think it's exciting, and I think that's actually a great segue into this next piece. North Dakota announces Vantis statewide UAS BVLOS network. Vantis will be overseen by the Northern Plains UAS test site, which has served as the state's one-stop UAS research and testing facilitator since 2013, bringing government resources, industry leaders, and public stakeholders to pioneer BVLOS activity. The North Plains UAS test site also drives approvals from the FAA and the FCC to bring the system together. There are four key components which are kind of combined to create the Vantis network. So remote infrastructure, surveillance sensors, command and control radios. Number two, backhaul data network, which is high reliability, low latency, and scalable. It is the unmanned system, so ground control in the aircraft itself. And then lastly, the mission and network. So data correlation and validation, maintenance monitoring, and system testing. We actually just had Nicholas Flom, the executive director from the Northern Plains UAS test sites, on the podcast about 2 weeks ago. Just excited to see this this development. I mean, when you guys see something like this, is this something that you think other states can take and replicate? We talked about doing BVLOS in more rural environments, but is this a model that if North Dakota gets it right, we can see other states start to adopt and employ?
I really think that building on all their lessons learned and understanding their infrastructure can make it replicatable for the various states and the organizations, and it also provides a standard for that location to be able to operate UAVs in that area.
So I'm looking at kind of some of the numbers here. So North Dakota invested $28 million for the creation of the unmanned statewide UAS BVLOS network. So that's pretty sizable. I know we always want more money in, but it's a sizable investment. I mean, that shows a level of confidence in what they're doing here, and not just for kind of research purposes. Like this is a real play. So. Yeah, I hope a lot of other states kind of see that and take kind of the lead there, and start implementing more programs like this. I know we've talked on this podcast quite a bit about BVLOS in a lot of different respects, and a lot of the experts that we talk with feel like it's not the end all be all, but it's certainly going to be the most awesome thing. So it's kind of like it's not what the industry back, but when we're able to do it at a sensible scale, it will be probably pretty awe-inspiring, the type of operations we'll be able to see.
Yeah, I think Tom Walker specifically mentioned, there's so much work you can do without flying BVLOS now. So to your point, Mike, there's still a lot that can be done with drones under the current frameworks. But yeah, this is definitely really exciting, and I hope this helps proliferate kind of BVLOS flight across the country, or at least just helps one of the federal test sites just get a lot of data that they can use and speed up the process of UAS integration.
So Jennifer, I mean, you might have a unique perspective on this, kind of looking at Bell, a vendor that's able to kind of straddle both civilian and military products and operations. Like, was engaging in civilian airspace with these products, or thinking in terms of kind of drones, fully automated systems, did what your company learn kind of in deployed military space equate in the civilian airspace, or was it completely kind of different perspective that you're working and building operations from scratch because of the nature of what civilian airspace is?
There is overlap between the commercial and the military spaces. We think in terms of military that may not be just, deployed to remote locations, that can be support internally to the United States, whether it's, border support or disaster relief support when that calls to it. there's also just the radio technology, being able to communicate with the aircraft beyond the side of the pilot, so we get into the curvature of the Earth. That's the same whether we're flying for a military operation or a commercial operation, to be able to safely and effectively talk to the aircraft where it's at.
Yeah, I always find it kind of fascinating because it's depending on where you sit in the drone industry, it can sometimes feel like two cultures, but there's clear kind of technology and process overlap that should make even more things transferable than probably are at current.
Correct. I think some of it may be the differences in priority in terms of what technology should advance faster on the military side versus the commercial side. If you're working in one space, they may want more radio communications that are maybe satcom dependent, as well as your traditional radios, versus maybe in a commercial space we're looking at LTE and cellular service instead of satcom.
Yeah, and also I'd expect kind of focus on the reliability of certain features, right? Because one of the things that I picked up from talking with Andy Thurling from New Air was, the idea that military operations might have actually a higher level or tolerance for equipment failure than commercial aerospace product, which deals with kind of Six Sigma level manufacturing. And that's not even to say that you would willfully make it less reliable. It's just that other kind of things on those systems might actually be more important to the single buyer in the case of the military versus the civilian airspace.
Most of my work to date's been focused on more the commercial, so I can't really a little bit, but I do see requirements for safety being strong on both military and commercial, but I understand the reliability could be standards might be different.
Well, I want to talk about this last article quick, and then we'll jump into the interview portion with Jennifer. And Jennifer, I pulled this article because I know you studied aerospace engineering in university, and I just thought that this was a really interesting kind of piece of aircraft that these engineers came up with. So it's a Raptor-inspired drone with morphing wing and tail. These engineers have developed a drone with feathered wings that give it newfound flight agility. The engineers have designed a bird-inspired drone with morphing wing in 2016, but their new model can actually adjust the shape of its wing and tail thanks to artificial feathers. That the drone changes the shape of its wing and tail to change direction faster, fly slower without falling to the ground, and reduce air resistance when flying quickly. It uses a propeller for forward thrust instead of flapping wings because it's more efficient and makes the new wing and tail system applicable to other wing drones and airplanes. So I feel like whenever we think about a drone, I think the first thing we think about is kind of the quadrocopter, four rotors. Jen, I'd just love to get some of your insight on kind of the status quo of kind of a drone aircraft that we think about, and then what are the advantages and disadvantages of doing a fixed wing versus something like this, which can actually change the shape of its wings, and how does something like this actually give it new agility? I would have honestly thought that four rotors would be able to be just as agile.
To me, I looked at that article as well as just the design and was fascinated by it.
Yeah.
I think man has always looked to birds to mimic in terms of getting airborne and for flight. So this is taking that a step further and just looking at how we might achieve flight using what nature has already designed. So it'll be fascinating to see them advance. In terms of traditional rotor copters and helicopters, it as well as your fixed wing vehicles. I would say even the vehicle used for the apps, App 70, one thing I forgot to mention earlier about it, it's not a traditional fixed wing vehicle, nor is it a traditional quadcopter. It is a transitional lift. It takes off, it's a tail sitter. It takes off vertically and then transitions over and utilizes its wings for forward flight. And that gives it endurance. So the balance between, do you go with a quadcopter, do you go with something that's like an apt or a fixed wing, will depend on the mission that the customer or the operator are looking to achieve. Each one brings something different to the table. And so I think that's the same thing with this. It'll bring something new to the table and give the industry something else to kind of continue to stretch and evolve with.
One of the things that I found fascinating watching the kind of video, the demo video they had, was like it to the naked eye, it looks like a bird when it's flying.
Yeah.
And what I'm also kind of just fascinated with, and just in general in robotics now, is reaching kind of a level of efficiency with either the parts or the software and how those things interrelate. We're coming to these form factors that actually do feel strikingly natural. Whereas if you look at kind of traditional aircraft, they're like these intelligent, minimum viable kind of mechanical systems that will get you to achieve flight. Whereas this is like, what else can we do? How else can we make this thing move? One of the things when CJ first started, I showed him a video of people flying remote helicopters and doing tricks with them.
Mm-hmm.
And those videos are kind of frightening at how the level of kind of agility you see in those, being able to turn it upside down and, with the spinning blades of death. What's interesting of this is that, I mean, it's all paper, right? I mean,
Yeah.
there's a kind of new level of elegance to this, and I know this is kind of just in its early phases, but it's the type of thing that kind of inspires me to see where we'll be, and hopefully this form factor will be around in 10 years with even more kind of capabilities.
And what'll be interesting to see is, well, this is shaped and formed like a bird. How can you take that technology and apply it to some of the traditional forms that we use for aviation in terms of, providing lift, spoilers, control, changing the way we apply control surfaces even.
Right. So like, just because this one looks like a bird doesn't mean we can't start applying some of the principles learned here or the mechanics learned here to current form factors to see if we could get improved kind of features there.
Exactly.
All right. I wonder if we'll see kind of a prop-based aircraft with wings and kind of integrate those two types of flight technology. So, and if anybody's just listening, we'll put this link in the description. You can see what this drone looks like. It's probably not like any drone you've seen before. So I think it's just the innovation is exciting. And it's kind of funny how we came almost full circle, and now we're back to taking ideas from birds after we've gone to multi-prop and fixed wing and eVTOL, and now we're back. But yeah, just love seeing the innovation. So Jennifer, let's talk about your career in aviation and in drones. I think I mentioned you had studied aerospace engineering in university. Can you talk about kind of the aviation industry, how you've seen the industry grow and adapt, and then specifically how you made your way into the drone side of aviation?
So I've been in the industry closing in on 24 years now. I started out working on the F-22 program, so a very fast supersonic vehicle, and have progressed to cargo vehicles, to tilt rotors, helicopters, and now looking at drones. And so this is kind of an interesting shift, that even looking at something that we see as maybe small, it's going to have such a strong impact on not only the aviation industry in terms of the automation that we're designing that can be maybe applied to some of the larger vehicles, but also to the communities that the drones serve in terms of your law enforcement, your medical support capability, as well as disaster relief support.
Right.
So my background's out of conceptual design and aircraft performance. Some of the early projects that I worked on at Bell actually were conceptual designs of UAVs and drones. So that was kind of fascinating to see those. And then I stepped away from that and moved towards, looking more at our tilt rotor applications, looked at helicopter and research. And then about 3 years ago, I joined the innovation team. And from there, began looking at back into the drone space again, helping support to get funding for the innovation team through proposal efforts. And I found myself leading the systems integration and operationalization project from NASA, from Bell.
So, my journey into the drone space and then aviation was from the drone first and much later in life. So I'm always kind of interested in like how far back to have a career like yours, because this is not the path of the average person, right? How far back do you have to be kind of interested in things that fly? I mean, is it like you were always at a really, really young age interested, or did it come from just an interest in engineering and this is the path you ended up choosing?
I was always good at math and science growing up, so that part of it was nurtured. I really didn't know what an engineer was until much later in my high school years when I was starting to look at colleges and what I might want to do. In terms of aviation, I grew up with the space shuttle and the program, watching that aircraft. Fly, as well as all the missions that we did with that. And I think that led me down the path to aviation and aerospace.
Jennifer, I want to talk a little bit more about the innovation team at Bell. Just sounds really exciting. What is the innovation team, and what are some of the focuses you guys have, and outside of drones and unmanned systems, what other types of innovations is Bell looking at, or what do you think the aviation industry might see in the coming years?
So Bell recently stood up a team dedicated towards focusing in on innovation and looking at not only new products, but also leveraging and exploring technologies to enhance existing efforts and projects. But we don't want to limit ourselves to just that team and the fact that it was stood up more recently, because Bell has had a long history of innovation in terms of its projects and activities since the start of the company. But this team here is focused in on various things. As you mentioned, we've got the looking at the air taxi space, and looking at the technologies that'll need to be built into that vehicle in order to make it safe and reliable for routine operations. We have the small medium UAS team. We've got looking at various variations of the APT platform, as well as smaller Part 1 drones on the lower end of the weight spectrum. Looking at research projects to improve our vehicles, both the military and commercial aspects of that.
And back to air taxis, where are we in regards to that technology? When, if you had a bold prediction, when do you think some of that technology and some of those services may be proliferated here in the United States? And then Lastly, Bell being an established manufacturer with helicopters, does that information, does that experience, do those learnings help create something, an air taxi or a type of aircraft like that that can fly a human as the payload?
I think our experience with manned aviation as well as certification efforts helps us to step forward with the knowledge and understanding of how to design the vehicles with safety in mind, as well as to explore the testing and the requirements necessary to provide an aircraft that can be certified at the end of the journey.
Mm-hmm.
We step through that. In terms of when we think that might be achievable, I think there's a lot of projects and efforts going on both inside of Bell as well as outside that'll be necessary for air taxis to be meet everybody. That includes infrastructure, understanding how these vehicles will operate in different cities and environments. One example would be both most of the manned aviation, whether it's the helicopters, whether it's the routine commercial flights that fly in and out of airports, have routes and corridors that they look at and fly in. That's one of the things that'll need to be looked at as we kind of move forward. What kind of infrastructure in terms of roadways in the sky that needs to be defined in order for those vehicles to move effectively and safely through the air.
So CJ asked a question from a national perspective. I'm curious because of what a big company Bell is, and then also, I mean, clearly you've worked with NASA, so there's great integration kind of in the entire kind of United with your company. But what's the international outlook for air taxis? Are we seeing in other countries faster movement? Are you working with other countries, or is it primarily a U.S. project for you?
I'm not working on the air taxis, so I don't have a lot of visibility
sorry.
on the certification. With our manned vehicles, we work closely with both the FAA and Transport Canada because we have for our commercial product line has operations up in Canada.
Have you seen how, I guess, the coronavirus impacted the drone industry in a number of ways? Has it at all impacted Bell with regards to the inside of the drone industry, the work Bell is doing in the drone industry, and I guess at a high level, what impacts do you see it having on the drone industry as a whole?
In terms of Bell, I think there's been a lot more inquiries in terms of what our product line can do to serve the communities that were impacted. I think Corona has shown a strong need and desire for touchless exchanges of packages and equipment, whether that's test samples from the large test sites that they had, being able to reach communities that are isolated to keep them isolated. They're going to need drone deliveries and packages. So there's a lot of opportunity there for growth that has been seen because of these impacts that we've seen for Corona.
Right. Wait, and before we let you go, Jennifer, I know we're coming up on an hour. We like to ask this to all the guests, but what excites you most about the drone industry and being part of it, and what, if anything, is holding the industry back?
What excites me the most, we have an opportunity to make a difference in this industry. There's a lot of things that are being made as firsts. I can't open up my news feeds without seeing this company achieving this first, or that company achieving that first, and to be able to make such a stepping stone and milestones with such the industry makes you get up and go to work and be excited every day. To me, the SIO was a very strong accomplishment, and I felt very proud for not only what our team did, but what the overall effort that we achieved. We learned a lot that will help NASA provide some insight into some of the regulations that'll go into the RTCA committees for drone operations, as well as the FAA for some of the rulemaking that they move forward with. I don't really see a lot holding us back. We are being paced by safety, but safety is important, and it's the cornerstone by which we have to approach every project and effort.
Yeah, one of the things that was part of my education in the drone industry, because if you look at kind of the early days of the super small UAS market, where the innovation in kind of quadcopters was coming from, was the lack of understanding that you were dealing with an aerial asset, and the aviation community, above all communities, prizes safety as kind of a first principle of everything they do. Do you think that if safety is the timeline that we're bound to, do you think that innovation isn't going to happen as quickly as maybe the market is putting pressure on it to happen? I mean, you seem like you wake up every day and you're excited to be working on this stuff. Do you feel like that is unwarranted, that we should actually just be kind of more realistic and that's enough to be excited about? I'm just trying to get a better idea into your kind of lens on the future of the drone industry.
I think safety can actually be an ability to harness innovation rather than something that hampers it. If you step through and have to solve a problem, sometimes if you look at it and say, okay, I need to get from point A to point B, the first thought is to go there the most direct route. And that route may be running across the street with busy traffic, and that's not the best way to go.
Frogger situation. Yeah.
Exactly. So but when you apply that lens of safety, as you say, you're going to open up new pathways. You're going to open up a new perspective on that, and that will lead to innovation, because that's the whole cornerstone of innovation, is finding a new way to do something that's more effective, more efficient, and safe.
It's interesting. I bet you detect and avoid technology wouldn't be as developed as it is now if there wasn't so much emphasis on making these things safe.
Agreed. That's when you look at detect and avoid, that's the whole aspect. We can put an aircraft in the air, but if it can't avoid those situations where it'll cause risk in the air, then it's no longer providing you what the mission that it needs to accomplish.
It's interesting with automated systems, I think, and just any automation at all. Bringing an example from sending an email out this week that nobody was looking at and it had the wrong thing in it, that something as mundane as that can cause damage to a business. And when you're dealing with automated systems in the sky, the risk is so much higher to create a situation that could cause not only property damage or loss of human life, that you really have to appreciate the emphasis that the aviation industries, or all the industries that touch aviation, really adhere to. And it's been kind of awesome for me to watch the drone small UAS industry mature in that direction.
Yeah. Safety first.
Yeah, there's not a lot of tolerance for failure up in the skies at all. So, well, Jennifer, what's top of mind for Bell as we close out this year and move into 2021? And I guess you and your team specifically, I know Bell is huge. So, more specifically on the innovation team, what's top of mind for the next, I guess, 13 months or so.
13 months. Well, we're closing out the systems integration and operationalization project. Now that I can actually say it without stumbling over it.
Me too.
So we're looking for other opportunities to continue to explore and continue to develop the beyond visual line of sight technology, in particular detect and avoid, and then continuing to mature and build on those lessons learned and continue to move towards a fleeted product.
Great. Well, we look forward to hearing you speak at InterDrone Online, December 15th through 17th. We thank everybody for tuning in this week. Like we mentioned earlier, today is election day, so don't forget to go out and vote. I know when everyone's hearing this, it's probably too late, but nonetheless, we had to say that. This podcast will be on the InterDrone website, be on SoundCloud, Spotify, Apple Music, YouTube, wherever pods are casted. We thank you again, everybody, for tuning in, and thank you, Jennifer Andrews from Bell, and we will see everybody next week.